Hi everyone, welcome to KPBHC online class English version. I hope life has been kind to you and all of you are doing well with your family members. Our today's topic is characteristics of ionic and covalent bond. Characteristics of ionic and covalent bond. I would like to discuss about number 1, melting point and boiling point. Number 2, solubility. Number 3, electrical conductivity. And number 4, formation of crystal. Under this topic. I would like to discuss about melting point and boiling point. The compound consisting of ionic bond are called ionic compounds, and the compounds consisting of covalent bond are called covalent compounds. Now, the boiling point and melting point of ionic bonds are higher than the covalent compounds because ionic bond contains positive ions and negative ions. Many such positive and negative ions are alienated in such way, in such three-dimensional way to form a crystal. That's why positive and negative charge creates a strong attraction force between ionic bond, and for this reason when it melts or boiled, it needs higher amount of heat energy. That's why melting point and boiling point of ionic bond is higher than covalent bond. On the other hand, in a covalent bond consisting of weak van der Waals forces, that's why the interatomic force of covalent bond is lower than ionic bonds. And for this reason, the melting point and boiling point of covalent bond is lower than that of ionic bonds because van der Waals force is very weak force. That's why the heat energy is needed less to melt or boil covalent compounds. So from the above discussion, we can be concluded that ionic compound has higher melting and boiling points than covalent compounds. On the other hand, covalent compounds has lower melting and boiling points than ionic compounds. Now, our next characteristics is solubility. To understand solubility of ionic compound and covalent compound, I will take a beaker with water and add some sodium chloride. Solubility. Look here. I will take a beaker with water and add sodium chloride. I will do the same things with washing soda, copper sulfate, and silver chloride. That means silver chloride. And these are ionic compounds, and I will take these compounds one after another and dissolve in water. From the experiment, we can see that sodium chloride, washing soda, and copper sulfate are dissolved in water. That means they are soluble in water. But silver chloride doesn't soluble in water, though silver chloride is an ionic compound. From this experiment, we can conclude that apart from some exception, ionic compounds are soluble in water. In this case, silver chloride is an exception. This is an exception, though it is an ionic compound, but it doesn't dissolve in water. Doesn't soluble. Now I will do the same experiment with some covalent compounds like naphthalene, kerosene, mustard oil, and sugar. Now I will take a beaker with water and try to add these compounds one after another. And from this experiment, I will see that naphthalene, mustard oil, and kerosene are not soluble in water, but sugar is soluble in water, So from this experiment, we can also conclude that apart from some exception, here sugar is an exception. Apart from some exception, covalent compounds are not soluble in water. And now finally we can observe that usually ionic compounds are soluble in water apart from some exceptions, and also apart from some exceptions, usually covalent compounds are not soluble in water. Now our next characteristics is electrical conductivity. Number 3 characteristics is electrical conductivity. Here I will do another experiment. I will take 2 beakers, one with solution of sodium chloride, and another will solution of sugar. And here in this beaker with the solution of sodium chloride, I will add two graphite rod or two metallic rod in each beaker, and add battery and a light with it. Battery and light with it. And after the completion of circuit, we can see that the light with sodium chloride solution is lit up, but light with sugar solution cannot. From this, we can conclude that the solution of ionic compound can conduct electricity, but solution of covalent compound cannot conduct electricity. The reason is that ionic compound contains positive and negative charge. Electrical conductivity is needed, the alienated positive and negative charge. On the other hand, covalent compound do not have any alienated positive and negative charge, so they cannot conduct electricity. Now our next characteristics is crystal formation. Formation of crystal. For this, I will do another experiment. Here, I will take two beakers with water, and add sodium chloride in one beaker and sugar in another beaker, and give some heat to dissolve as much as sodium chloride and sugar as possible. Now I will take these two beakers for some days with a cotton liner, along each of the beaker, and after some days we will observe that this cotton liner has some crystal of sodium chloride, and this cotton liner has some crystal of sugar chloride. From the experiment, we can observe that both sodium chloride and sugar form crystal, but the sugar is exceptional because usually covalent compound doesn't remain in crystal form, or covalent compound doesn't available in crystal form. Usually ionic compound remains in a crystal form. Now, from the characteristics of ionic and covalent bond, we can differentiate between two types of compounds: ionic compounds and covalent compounds. Such as, at first we can say the compounds consisting of ionic bonds are called ionic compounds, and on the other hand the compounds consisting of covalent bonds are called covalent compounds. And number two difference is Solubility. Ionic compounds usually soluble in water, and covalent compound usually do not soluble in water. And number 3, electrical conductivity. Ionic compounds conducts electricity, and on the other hand covalent compound doesn't conduct electricity. And formation of crystal. Ionic compounds remains as crystal form, and on the other hand covalent compounds doesn't remain as crystal form. And now I will discuss another things which is related to solubility. Why ionic compounds are soluble in water? I will discuss it with figure of water. Why ionic compounds and some covalent compounds are soluble in water? The reason lies in the structure of bond, structure of water. Just like this is the structure of water, and this is the outer shell of oxygen. And due to here hydrogen share electrons with oxygen and form bond with oxygen, and these sharing electrons, these two pair sharing electrons move a little bit towards oxygen due to the electronegativity of oxygen is higher than hydrogen. That's why here creates a partial negative charge, and here creates a partial positive charge. When an ionic compound dissolves in water, suppose sodium chloride, and ionic compounds has cations and anions, you know, this cation is attracted by the partial negative charge of water, and this anion is attracted by the partial negative charge of water. Thus ionic compounds are dissolved into water, and water is itself is a covalent compound, but the covalent compound which has partial negative and partial positive end are called polar compounds. And I have already told you some covalent compounds also dissolved in water. But why? The covalent compounds which carry partial positive and negative charge, that is which are polar compounds, only those covalent compounds are dissolved into water. Because for example methanol, here this oxygen has higher electronegativity than hydrogen, and it creates partial negative, and here creates partial positive charge. That's why when we add methanol into water, then partial negative charge of methanol is attracted by partial positive charge of water, and partial positive charge of methanol is attracted by partial negative charge of water. Thus some polar covalent compounds can be dissolved into water. I think all of you have understood everything that I have been discussed so far. No more today. Thank you everybody. Take care.